G'day, my name's Warren Toomey and I want to share with you some things I've been doing with the XV6 operating system in the middle of 2016. I've taken the basic system and I've added some runtime and some libraries to make it a little bit more useful. I'm the guy in the picture at the top. I'm recording my desktop, so you'll only get the desktop and you won't have any video of me talking along the way. So what is XV6? If you're interested in how operating systems work, and in particular how kernels work, then I'd really highly recommend that you look at the XV6 kernel. It's a very minimalist kernel. It's only about 5,000 lines of code. It comes from MIT with an MIT license. And not only is it small, which makes it much more easily for you to digest and to understand, but it actually comes with a great commentary booklet in the same vein as the Linux commentary did with 6th edition Unix. So let's have a quick look at the website. So this is the XV6 website. There's the URL at the top. And it explains why they decided to create it. They were using 6th edition Unix and the Linux commentary, but they found that, that's based on a PDP-11. Nobody has one of those anymore. So they effectively rewrote a very similar system for the 32-bit x86 architecture. The really nice thing about XV6 is it comes with a great textbook / commentary which explains how it all works. So if you click on that link, you get this URL, this PDF document, and they seem to be updating it every couple of years each time they run the course. Let's have a look at the contents. So it really goes through the basics of operating systems. So the API, system calls, how they're organized, memory management, dealing with interrupts, how do we make sure that the kernel all the data structures are locked, how do we do process scheduling, how do file systems work, all of that sort of stuff. And every time they talk about a concept, they relate it back to how the operating system itself works, which is excellent. Alright, so the official repository is here on GitHub, and I'm going to have a walk through that in a minute. And once I've shown you the official repository, I'll then have a look at what I've been doing with the XV6 system to extend it. Alright, so let's hide the slides just a minute and get rid of the web page. And let's have a look. I've cloned the repository. And here's what you get when you download the official XV6 repository. Everything's in the top level. So it's a little bit hard to distinguish the kernel from the libraries and from the user land that comes with it. So let me just give you a bit of a quick tour. We've got some boot code over here, boot assem, boot main. We've got devices like the console. Where's IDE? There's the hard drive. We've got the UART console, whereas other UART device over there. We've got kernel sections, for example. We've got the kernel section on, where's a good one that I can pull up? Generic syscall handling, syscalls that are related to file operations, system calls that are related to process. We've got the actual core code of dealing with processes, although exec is a little bit too big, so it's got its own bit of code in a separate file. The file system is a single file, plus obviously the header files, and dealing with memory management, page mappings and that sort of stuff, dealing with locks and contention on data structures within the kernel, and one more thing I'm going to point out, which is multiprocessor support. So that's the kernel effectively. Along with the kernel, obviously we need a runtime, so we've got a single file, which is the library. There's only 9 or so library functions. And then there's only a handful of runtime user mode programs. So, for example, if you want to cat a file, we can cat. I think there's an ls, yep. There's a link. Is there a move? No, I don't think there's a move. No. There's a shell. So it's a very minimalist in terms of kernel, makes it easy to understand, but it's also very minimalist in terms of what lives above the kernel. That's the libraries and the runtime. Alright, so let's have a look at it in action. I'm going to show you how we can make the system, and I'll show you how that we can run it with QEMU. So if you just say make, you'll build the image which has got the kernel on it, and at the same time that will build the file system image. If I say make QEMU, then it will build the images and then launch it in the QEMU x86 simulator. So let's do that. So I should be able to type make QEMU, and very quickly we get two windows in operation. We've got a VGA window, and there's our prompts, our shell prompts, and we actually get a mirror copy of that on the serial port on the UART. Alright, so if I type ls, then there's only one top level directory, the root directory. We've got a text file to have a look at. We've got some programs, cat, grep, ln, ls. There's not an awful lot in terms of what you can do with the runtime. So while the kernel is really nice and small so that you can understand it, from my perspective, I thought the runtime was a little bit too cut down. In particular, when I first launched Make QEMU, I went, where's the VI editor? How can I actually make some files and do things? I mean, all I can do really is have a look at the contents of the README file. I can probably make a directory. I can probably cat the README file into another file. I think I can probably, I can't even do ls-l because the built-in ls doesn't have -l. I can list the A directory. I can cat, obviously, that file which I've copied, and I can remove the file, and of course, to remove a directory, directories are really just like files, so we can just, I can't even rm a. And that's about all you can really do with XV6 in terms of using it. So in terms of understanding it, it's really good. In terms of using it, to me it feels a little bit too much like a toy system. So what did I want to do? Let me just get out of QEMU, Control A X, we'll get rid of that. What I really wanted to do is to improve this runtime. You know, it's only got 9 library functions, and those are things like string copy, string cat, memcopy. There's really only a tiny handful of printf, that sort of things. And there's only those 10 programs that are really there to use when the system is running. So my goal was to take the minimalist kernel and try and keep it as minimal as possible, because obviously that's what MIT are using for teaching. But on top of it, add a set of libraries from BSD and a set of programs so that it actually feels like, I mean, I remember when Minix 1.1 came out, you know, because I'm old as the hills. So I want to be able to use a system and actually feel that it's actually a useful thing. One of the constraints, though, with trying to do this is that because XV6 is so cut down, there are a whole bunch of things missing. For example, there are no users. There is only the implicit user, which is root. There are no groups. No files have permissions. You can do anything that you like to any file. Things like signals are missing. A lot of devices are missing. To implement things like VI and less, you need to have raw terminals where you don't get echo and you get one character at a time. There's not even a system call like lseek. There's no system call like time. Things like that. So there's a bunch of things that are missing. So there's a bit of a tension. I want to extend the runtime without changing the kernel. But I know that to get even the minimalist system up that I would treat as a real Unix system, I'm going to have to extend the kernel along the way. So what do I need to do to make this happen? Write stub routines for things that are never going to exist. So things like signals, things like chmod, chown, get UID, get GID, all of those sorts of things are never going to exist. So just return something that at least makes some sort of minimal sense. Sometimes I can write routines that are going to simulate the functionality. A good example would be stat, to get the details of a file on the system. There is no stat system call. XV6 doesn't have it, but it has got fstat. So if you've got an open file descriptor, you can fstat on the file descriptor. So how do we implement stat? Well, simply we open up the file, do an fstat, close the file descriptor down, and return the stat buff So we can do things like that to simulate functionality. So I've already said I don't really want to modify the kernel too much, but I do want to port as many BSD libraries and programs as I can. I've gone for BSD because I know it pretty well. I have been using FreeBSD for ages. And the license is a bit more compatible with the MIT license than, say, any of the GNU licenses. Alright, so I did promise that I was going to try and keep the kernel changes minimal, but I did have to do things. So what did I have to do? I needed to implement lseek. You've got to have lseek if you want to be able to move around a file that's open. I've implemented ioctl not because I wanted to, but because I wanted to be able to do term iOS and get the terminal characteristics and change them as well. So I've implemented ioctl just so that I could set and get the terminal characteristics. Obviously, we need to know what the current time is. We need to be able to change a directory. There is a chdir command, but there isn't an F1, and a lot of BSD utilities need that. Open doesn't have a bunch of flags. We can't append a file. We can't truncate a file. I needed to add those. Exit and wait weren't exchanging values. Now, that's really crucial for things like the make program, because make looks at the exit value of a program to decide whether it succeeded or whether it failed. So we need exit and wait to exchange values. There was a very small file size, 61K I think it was. I needed to bump that up. And by default, XV6 only gives you a one 4 kilobyte stack, one page for stack. And a bunch of other things like actually returning error no values and a bunch of other devices. So these are the things I had to make change to the kernel in order to get the BSD runtime up and running. Overall, I think it cost me about 300 extra lines, so instead of it being about 4,900 lines, it's now about 5,200 lines of kernel code. I've added heaps of library functions, I'll show you those in a minute, and a bunch of programs as well. Alright, so before we get into looking at the code, I'll just give you a quick top-level tour. Instead of having it all in one top-level folder, it's now split up into a bunch of subdirectories. Boot for the boot code, kernel code is in kern. All the libraries are now in lib, including the code that is specific to XV6, the routines that are stub routines and the ones that simulate functionality. All the commands are now in the command directory, and the make fs tool is the only tool that's in the tools directory. Alright, let's close down the slides and actually have a look at this. Oh, ls, so you can actually see. Alright, so the boot code is in there, there's not much in there. I think there's only 2 or 3 files, yep. The kernel code, maybe I should do L to get a column. Alright, so now we've got only the kernel code in the kern directory, so it makes it a bit easier for a reader to find just the kernel code. So now we can see that, yep, there's blocking codes, we've got block IO, we've got file functions, the file system, drivers like IDE and the UART and the keyboard. So it's a little bit easier to spot just the kernel code. And the kernel gets built in this directory as well. If I go into the library directory, lib, here are the libraries that I've imported from BSD. Strings, standard IO, the standard lib, a whole bunch of Unix functions. We've got Henry Spencer's regex and another regex. BSD has 2 of them, I'm not sure why. We've got cursors, which includes, and term cap as well. There's a little bit of locale, but not a great deal. And a couple of other things along the way. The really, really specific to XV6 stuff that I've had to simulate or stub is in the XV6 folder. So let's have a look at those. So things that don't exist, like chmod system call doesn't exist. So just return 0 or to say that it all went okay. Chown doesn't exist, so we can do that. Dupe2 is interesting because there is no dupe2, there's only dupe. So how do you dupe 2 when you can't specify the second file descriptor? I've actually borrowed this. I think this comes from Minix or BSD. So we loop we loop duping until we get the file descriptor we actually want. And once we get out, we can then close down all the file descriptors we opened and return the file descriptor that was the one that we actually wanted in the first place. So it's a little bit of a cheat. Obviously, it's a simulation, stuff like that. If I have a look at the stat simulation, we do the same sort of thing. We don't have stat, we've got fstat. So we open up the path, we do an fstat on that path, on the file descriptor that comes back, and then, of course, we can return the buffer and also return the result of the fstat in terms of its -1 or 0, that sort of thing. And, of course, there is no links. There are no links in XV6, so I can simply just do a stat instead to do a simulation of lstat. All right, so those are the libraries. A decent bunch of libraries instead of 7 or 8 library functions. Let's quickly go down to the command level. We've got a bunch of one-file commands in simple. We've got a bunch of multi-file commands that live upstairs. So less, make, MD5, the old nroff from BSD, sed. The shell, this is the version 7 shell, and I'll talk about that in a little while. Well, let's have a look at what's in the simple folder. Let's do simple and do an L so you can see them a bit better. I've tried to find the most important Unix commands that I would say we need. So, copy, cat, link, rm, move, those sort of things. What else? Sleep, split, tar. You've got to have tar. You've got to have tail. You've got to have head. So all of the ones that I think are really important. You've got to have WC, unique, all the ones that I would use all the time. I've borrowed from BSD and brought them in. All right, so let's actually bring the system up. So I can still say make QEMU to bring up the system. It's going to take a bit longer to build because we've got a bunch of libraries, we've got a bunch of commands, as well as the kernel to compile and bring up. I haven't got around to fixing all of the warnings with miners wall. I will get around to those at some point. So yes, I've been working to try and get those fixed. All right, we've now got 2 windows. This time I've separated so that we've got 2 logins effectively. We've got the VGA and keyboard console, and over here we've got our UART, our serial port, and I can do separate things in this one, and it doesn't affect the user that's logged in onto the other one. You'll also notice that I've made a whole bunch of directories. So we've got a bin directory, a dev directory, and use of the directory at the moment is just for the man pages. So if I actually do, and now we've actually got a decent ls, an ls that actually takes -l, which is excellent. So let's do ls-l bin, and you can see there are a whole bunch of useful commands in there that we didn't have with the original version of XV6. All the usual tools that you would like to have. So we should be able to, if I'm still upstairs, I think I am, I should be able to look at the README, this time 1 page at a time, instead of having to scroll backwards because I'm using cat, which is excellent. Of course, I've got an editor now. I've ported VI, a very simple version of VI called Levy. I can't remember the name of the author. I should be able to tell you, but I can't. And okay, so I've got VI hard-coded into my fingertips, so now I can actually use the system and make changes to files, exactly that sort of stuff. Dev directory. Let's have a look at what's in the dev directory. ls-l might be a bit better. Originally we only had console and that lived in root. I've moved everything out to their dev directory. I've created raw disk devices so that we can get the blocks off the 2 disks. We've got the serial port separated from the console port. And of course you've got to have dev-null on any Unix system, like it's compulsory, it's mandatory, so I've built those as well. What else can I show you? Etc. is quite interesting. Obviously, there are no users, so there's no need for a password file. Everybody is root, so there's no even need to map user ID to names. But one thing is interesting is that XV6 doesn't have an environment, doesn't have environ when we do execv and that sort of stuff. So how do we get around it? So whenever you do get env from a program, what it'll do is that it'll actually suck up the contents of the /etc/env file, and it will populate the environment array based on the contents of what's in this file. So we've got termcap working. Our terminal is xterm small 24 line by 80. The path is only there because everyone wants to have a path, but there is only really /bin. So it's now actually quite useful. I've got vi, I've got less, we've got make, we've got nroff, we've got man pages. I've tried to change them to reflect the state of the commands. Oh, it's shells. So we're going to show you the shells that we've got. If I go into bin again, you'll probably see, where are they? These are the original XV6 commands: old cat, old grep, old ls, old rm, old wc, and the shell is the one that came from XV6. But we've got two other shells. The basic shell doesn't have meta characters, so if I do echo bin /a*, of course we're not going to actually get any expansion on that. So there are two other shells that you should look at. This is the real version 7th edition Unix shell. So we can do things like while loops, for loops, if tests, all of those good sort of things, which I won't show you. The other shell that you should look at is the wish shell, which is a shell that I wrote ages ago. What makes the wish shell nice is that you've got editing, so that you can actually go back. You can clear lines, that sort of stuff. And of course it's got meta character expansions in it. So if I do... Oh, there are no A things. Okay. Oh, okay. Let's do ls/bin/w*. Alright, so we got meta character expansion. You should have history. Hopefully we've got history. Yep. And of course you've got Control P to go backwards in history as well, which is really, really nice. So it really makes it nice. So I can say, for example, cat/tab, and it expands that into the README at the top of the system as well. So that's the sort of thing I've been working on with XV6. So it now has a decent set of BSD libraries. It's got about 60, I think, BSD commands. But there are still a couple of things that don't exist because of XV6 and the way it's been designed. There is no way to control C because there isn't any signal handling, so you don't get sigterm, sigint, sighup, any of those sorts of things. I mentioned the environment in etc/env. The file size has gone up from, what was it before, just over 60k up to 267 kilobytes in size, which isn't huge, but it's fine. I've bumped the process stack up to 3 pages, but it's fixed. It doesn't grow as the stack grows, which can be a bit of a problem if you want to do recursion. A couple of tips. If you do want to see the process table, we don't have a top, but we can do Control P in the VGA console, and we get a little bit of information about what processes are running. So we can see that there are processes 1, 2, 3, 4, and 12. The wish shell is PID 12, and they're all sleeping, waiting for someone to do something to type at the keyboard. Okay, and to get out of QEMU, type Control AX, and that will, I think on the UART mainly, and that will kill off the emulation. Okay, so that's XV6 with a bunch of BSD libraries and user mode programs running on top of it. Hope you've enjoyed this and hope you found it illuminating and useful.